Hello, everybody, and welcome to today's ePrime 3 webinar on sending triggers with task events. I'm your presenter, Kimberly Baroni. I'm the Product Service and Support Coordinator here at Psychology Software Tools, and very happy to be hosting. We have quite a bit of information to cover today, so we're just going to go ahead and get started. Thank you so much for everybody who joined a few minutes early and got ready. Let's take a look at the agenda. After a brief introduction, we're going to do an overview of the why and the what concerning task events. Then we're going to dive into the details of task events and run a live demo where we illustrate sending task events with Kronos. We'll do a second demonstration illustrating how to send task events over the serial port. Finally, we'll take a look at some common points of confusion that hopefully the examples have illustrated and clarified, and go over some recommendations. And time permitting, we'll be able to share a few questions and hopefully answer them from the folks participating. Also, please note that this webinar is being recorded, and the recording and our supplemental materials will be made available on our website within a few days. All right, during the webinar, please feel free to ask a question during the webinar by using the Q&A button. I'm pleased that our terrific support team is standing by, and they'll address whatever questions they're able to. If we don't have time to get to your question, if your question is too complicated to address in this format, or you think about it later, then we strongly encourage you to please email us at support@pstnet.com with your question, and we'll be happy to help you out there. And again, you can review the webinar once we post it. Speaking of webinars, please make sure to follow us on one or more of your favorite social media outlets to learn about upcoming trainings and additional webinars. All right, that concludes those opening remarks. So getting right to the question, why would I want to send a trigger? What is the utility of it? How is it useful? Triggers are useful in a couple different ways. The most common way is if you want to add a marker to some type of external data stream. Possibly you're collecting EEG data, FNIRS data, something like that. And you want to be able to identify or insert key experimental events into that data stream. Some of the most common options are wanting to mark when a critical stimulus appeared on the screen, or if you're presenting sound, when a sound file started to play, or possibly when did the participant make a response. However, you can also send triggers to communicate or drive external equipment. We recently had a very interesting interaction with a user who was performing a tactile stimulation task. So they needed the ePrime computer to trigger their air puff device to present puffs of air of varying intensities, I believe it was on the participant's fingertips. We also worked with a user a while ago who was doing another interesting study where they needed ePrime to trigger the release and then the end of dispersing different aromas from an external aroma pump device, excuse me. What kind of triggers can be sent? What kind of information are we talking about here? Most commonly, users are sending some type of digital value. There's a variety of devices that can transport these triggers, and we'll get to that in a moment. But if you're sending a digital trigger, you can send a 5-volt TTL signal. So maybe you just need a simple signal to denote the start or the stop of one of these key experiment events. Maybe you need to denote those events, but you also need to convey a little more information. For example, you want to be able to distinguish not only that a stimulus was presented, but that it was a particular category of stimulus. So maybe you're doing a priming task and you want to denote a 1 if it was a congruent task, or 2 if it was an incongruent task. You can also send string values. For example, maybe you need to send the string start or stop. For example, if you're communicating with one of these external devices and they need to receive a particular string as a trigger. In addition to sending digital values, our Cronus device also supports generating analog values. So you can send a 3.3 volt analog signal. You can also generate an analog waveform. So that's the majority of the types of information you can send. And just to give everybody a simple example, this is a recording made using BioPAX equipment. In this particular case, they were collecting galvanic skin responses. So that's this continuous analog data being recorded by BioPAX equipment. But you'll see up here, there were various markers. I apologize, it's probably not super clear, but these are a variety of 1s and 2s across the top. These represent the trigger values that are being sent from the ePrime experiment as it's running to the BioPAX equipment. Since we're talking about sending signals, you might ask, well, can ePrime receive signals? And the short answer is yes, indeed, ePrime can receive signals from external equipment. That is not the focus of this particular webinar today, although we actually are going to take a look at a simple way of receiving some signals when we get into actually both of our live demonstrations. What I illustrated here is an example using Cronus, which is off here to the left. You'll get a better image of the Cronus device itself shortly. This device here is our I/O expander. That allows you to send out 16 digital outputs, receive 16 digital inputs, and also send and receive analog signals. This is an illustration of a custom slider bar that was created and from a user's own materials, and the green and the orange wires indicate signals coming from the slider into the analog in for Cronus. So just an example to let you know that yes, indeed, we can receive signals. I have a reference at the end of the webinar, of this webinar, linking you to another webinar that's focused solely on analog in. But just keep in mind, you can certainly receive signals, but we're going to focus on sending signals out. All right, just to make sure that everybody's on the same page, although I assume most of the folks here have some familiarity with ePrime and with the eStudio application for building experiments, I just want to make sure that we're all starting from the same baseline. So this slide is just illustrating a simple experiment implemented in ePrime in the eStudio application. So eStudio is a GUI that provides a drag and drop interface that allows you to drag experiment-like objects from this toolbar here into the Experiment Explorer window, which is where you structure your experiment. And there are many different types of objects supported in eStudio, but the three most critical ones are highlighted here. Lists are used to define your sets of your experimental stimuli or your exemplars. So in this example, we have a block list that's going to present blocks of trials, and then there's a trial list that's going to present the individual trial. So that will contain the individual stimuli, letters, pictures, images, whatnot. Procedures define the repeating elements of the trials, the blocks, and the sessions. So here we have a trial procedure that consists of 3 events. On every trial, we'll present a fixation, a stimulus, and then a feedback object. And then we have another procedure called a block proc that represents repeating that set of trial procedures for as many blocks are defined. And then the outermost procedure is this larger session procedure, which consists of, at the highest level, we'll present some instructions, we'll present a series of blocks, each of which presents a series of trials, and then we end up with a goodbye screen. And lastly, this particular experiment illustrates both a text and a slide object, which are used to present stimuli and collect responses. Right, so that's the basics of eStudio in a nutshell. All right, so what is this about task events? What are task events, and why are we recommending we use those to send triggers? You can think of task events in terms of cause and effect, where the event part of it represents the cause. What experiment event should cause something to happen? What do we want to be denoting in the experiment? What do we want to set off our series of actions? And then the task is the effect part of cause and effect. What should actually happen once that experiment event occurs? So to look at, again, a couple more specific examples, very, very common events are, I want to know when a stimulus is presented, when does the stimulus come on screen? Or when does the audio file start to play? When does the movie file start to play? Something like that. You also may be interested in knowing either when the stimulus was removed, or you want to denote the entire time period that a stimulus was on screen. Alternatively, you may want to know when the participant made a response. Those are all common experiment events that folks need to denote. And then the task is what should happen. And again, we're sending out information. So either sending a marker to an EEG data stream or the GSR example we just looked at, possibly you need to output an analog waveform, pardon me. Why do we recommend using task events? They're one of our favorite topics here in support. We're always encouraging people to use them. Well, there's two reasons. A general reason is that a task event can be completely defined within the eStudio GUI. It does not require any eBasic script to be added. And in general, we always encourage researchers to implement tasks using the GUI where possible. Those of you who are fairly experienced with ePrime and eStudio in particular may realize that pretty much anything you can do in the GUI, you could also implement in script using eBasic script. But we recommend using the GUI because it's more understandable, it's less error prone, it's a more robust, easier to maintain solution. So we will always recommend, almost always recommend a GUI-based solution over script. But there's another more specific reason why task events are recommended. And that's because they offer the tightest integration and the most accurate timing to perform that action based on what happens in the experiment, based on the event. There are a variety of legacy methods that we still see folks using to denote, I want to do X when the stimulus comes on screen, or Y when the stimulus goes off screen. And while those options are certainly accurate, task events were specifically designed to be able to respond as quickly as possible. Now, the difference we're talking about here for many, many people will be negligible. Task events are typically executed in a sub-millisecond to 1 to 2 millisecond time period. They're very, very quick. A non-task event may be executing within 2 to 3 to 4 milliseconds. So there's often not going to be a big difference, but it still is the best option that we can offer. So we strongly encourage everybody to migrate to using task events versus handling it in script. Okay, what is it about these task events? How do they actually work? There are 3 basic pieces of information that you need to be able to specify in order to create and define your task event. First of all, how is this trigger value going to be sent? How is this digital or analog signal actually going to be transported from the computer that's running the ePrime experiment to whatever external equipment I'm communicating with? So how are we going to send it? What value are we going to send? Do we need to send just any value that just demarcates this is when something happened? Do I need to send 2 different values? Can be any 2, but 2 different values to delineate 2 different conditions. Do I need a specific string value to be sent? What needs to be sent? And then finally, what method are we going to call when we're constructing the task event to send the marker? And we'll be looking at all these components in detail. I do want to note, though, that the second and the third steps are where there's a lot of confusion with users, because, as hopefully is clear from this image, it's a bit of a chicken and an egg problem. The value that you're going to send you can only send certain values using certain methods. So some folks get into this with, oh, I don't know what method I need to send. They get stuck on that, but they haven't really thought through, or they're not clear on what values they need to send. They don't know about that. Or folks are clear about the value and they get tripped up on the method, because as we'll see, there's a couple different equivalent methods that you can call, and hopefully it'll be clear by the time we finish that for many of these, there is no difference between them. It's just a matter of choice. You just need to be consistent with how you're structuring things. So it can be a little bit tricky. So it's a little bit of an artificial breakdown to say, pick your channel, pick your value, pick your method. But hopefully you'll see how that all comes together. Question number 1, how is the trigger value going to be sent? We support a number of different ways to convey trigger signals. You can have a physical connection. We'll be looking at Chronos shortly using our Chronos device. Don't worry if you're not familiar with that. We'll get you up to speed shortly. But Chronos is a physical device. We'll take a look at that in a minute. That Psychology Software Tools manufactures, and it can be used to convey signals. We also support communication via the parallel port or the serial port if you happen to have those on your device. And you can also send triggers using a socket device through, most people think about it, basically your Ethernet connection. We also support wireless connections using LSL. LSL can be wired or wireless, but most folks taking advantage of LSL are using it wirelessly. All right, so those are different ways you can send the triggers. What value are we going to send? One reason that sometimes our support team has a little trouble advising users on this is that this is determined in part by the needs of your receiving hardware and software. So whatever external equipment you're working with may have an impact on what values it's expecting, what values it can accept, what data types it's looking for. So you need to understand what your receiving equipment needs to receive. And it can also be determined in part by the needs of the experimenter. Putting aside from the moment how we get our specific value identified, then the third question is, what method are we actually going to use? And today we're going to be focusing on digital signals, since that's the most commonly used task event types. So digital signals ultimately are sent from the EEPROM computer out as binary values. But digital signals can be specified as either an integer, a base 10 value, or a binary, which is a base 2 value. All right, so those who aren't familiar with binary are going to talk a little bit about math, but not too much. Binary numbers, as I said, are base 2. Binary numbers are represented as bits. So as compared to base 10 numbers, where the rightmost column is the ones, the next column over to the left is the tens, the next column over to the left of that is the hundreds. Binary numbers are representing 2 raised to a certain power. They are numbered from right to left, and the rightmost bit is referred to as the least significant bit. They're also numbered starting with 0. So that might strike you initially as a little odd. The first bit is bit number 0. It's not bit number 1. But that actually makes sense, because what each bit position represents is the number 2 raised to the bit position power. I'm not sure how well you can see this on the slide. The text is kind of small. But bit number 0 down here, this represents 2 raised to the 0th power, which is the number 1. The next column over represents 2 raised to the first power, or the number 2, and so on and so on and so on. So this is why the first bit position is bit number 0, because it represents 2 to the 0th power. There are 8 bits in 1 byte, so this representation here of 8 bits numbered 0 through 7 represents a single byte. If you have a 16-bit number, 16-bit value, that's also referenced as a 2-byte value, and you'll see where that's relevant later. Okay, so programmers, computer programmers, often think in binary. That's just the way that the brain works. Most of the rest of us think in integer values. So how can we deal with this? It's actually fairly simple. You have an incredibly easy to use tool available on your laptop, I'm sure, if you've got a calculator that you can put into programmer mode here. And I have a screen grab of this. It's a super easy way to go back and forth. In this mode, here a decimal is referencing base 10 or integer values. I have a decimal value of 1 specified here. This part of the calculator, binary, shows me how that number would be represented in binary. It's only showing me the lower 4 bits because the upper 4 bits in this byte are 0. I don't need them to be set. But this is illustrating, you can type in an integer value of 1, and you can see that the binary value is a series of 7 zeros followed by 1, which represents 2 to the 0th, which again is the number 1. If you needed to present the integer value 2, that's represented in this binary pattern. You see the 0th bit in this case is 0, and the first bit is 1. This is the full binary pattern here, and it's 2 to the 1st. So it's easy to switch back and forth between binary and integer values. So going back to the question of what task method is used. So the specific value is a function of the receiving software. The value itself may be irrelevant. And the analogy I like to make is similar to encoding an independent variable. Let's say you're presenting a go, no-go task. You should surely have an independent variable that represents my trial type. Was it a go trial or a no-go trial? I could encode those two levels of that variable in many, many different ways. I could encode it as 1 represents go and 2 represents no-go. That would be a sensible way to do it. In EEPROM, you can log strings, so you could also log the string go or no-go. Or maybe you want to make a 10 represent go and 11 represent no-go. You could choose, as the experiment designer, you could choose to say -5 for trial type represents a go and 10 represents a no-go trial. The mapping is arbitrary. You just need 2 unique values. Or you may need an actual specific value. Going back to the example of the air puff tactile stimulation, maybe 1 represents the lowest level of stimulation and 10 represents the high. So you first need to determine what values you need to send and then pick the method. And as the prior screen showed, you can think about those numbers either in integer or binary, and task events can be defined using either method. We're very shortly going to jump into the actual eStudio interface, and we're hopefully going to be able to run an experiment live. But because the task event interface is a little bit busy, I wanted to take a minute to look at these screen grabs real quick to show you close up some of the components we're defining. When we go to define the task event component of the task event, again, that's what event do I want to represent? You will get a fairly long list of potential events. The first 5 shown here, circled in green, represent stimulus presentation related events. Again, we've talked a lot about the stimulus onset time, which is by far and away the most commonly used. But there's a variety of other, you might recognize these as our time audit metrics, but you could use any of these time audit metrics. When the stimulus went on screen, you could use the offset time or any of these other ones. Then there's a set that are related to the participant response related events. And because there are many, many ways to represent that response, there are many, many different options here. These are indicating how your input masks are created. So this is showing me I have an object named stimulus. The first input mask I've defined is a keyboard input mask, and perhaps I want to send one trigger when they answer correctly, or send a different trigger if they fail to make a response on that trial, or send a trigger when they've reached the maximum count. So any of those response values can be used for the trigger, for the event. Now, the task component, this is a close-up of the 2 chunks of information you need to specify. On the left is where we decide how is that trigger going to be sent. And the most crucial field here, the first one that you really need to decide is this task. And you'll see, we'll see in a minute, this is a drop down. Here I'm showing you that I have chosen Kronos as the device to send the task event out. And here I've chosen the method that I want to choose. In this case, I'm going to call digital out set bit. I'm going to set an individual bit. So what's the device you're going to use and which action are you going to use? Then over here on the right, outlined in orange, is where I specify what the specific trigger value I'm going to send is. In this example, I'm choosing to send a custom value of 14. So I'm specifying bit number 14 is the one that I want to set. And the data type is telling me how E prime is to understand this custom value. In this case, 14 represents an integer value. So I want to make sure you had a clear vision of that in case you can't make out some of these items clearly. All right, getting to Kronos in our demonstration. For anybody who's not familiar with Kronos, this is what the Kronos device looks like. It connects via a USB connection to your E prime computer. Kronos has a lot of features built into it. As you can see, there's 5 blue response buttons. There's a voice key, which isn't shown, but you can record a vocal RT. You can see here there's LED lamps that can be set to different colors. Kronos can also be used to present sound, and it has a lot of timing advantages over your standard sound card in your computer. It can also be used to record a vocal response. But we're not focusing on those features today. We're going to focus on Kronos's ability to send digital signals, but also noting it can send analog signals as well. What I'm going to be using to send the signals today is this device, which is our Kronos aux I/O cable. This cable comes with every Kronos device. This component connects to the back of the Kronos, and you can see there's a whole series of wires. These wires convey a variety, perform different functions, but there are 2 wires that are capable of sending a digital signal out. And there are 2 wires that are capable of sending a digital signal in. So for the purposes of just demonstrating how to set up a task event, we're going to show you how you define the task events to send out a signal either over the light green teal output, which is output 14, or the purple output, which is output 15. But it's tough sometimes for users to actually confirm what's going on and to have confidence that the task event that they're defining to actually send those triggers out is indeed actually sending those triggers out. So what we've done in this demo is connected our output wires to our input wires. And this is where we can illustrate receiving signals. So we set up a task event to send out a trigger, and then we look to get that response back from Kronos. And we're able in that way to confirm indeed that those signals are being sent out. And we'll see how all of that works shortly. As I mentioned, the aux I/O cable provides 2 different digital outputs. When we're talking about Kronos's digital outputs, these outputs are zero-based, just like the bit numbers are zero-based. So Kronos is capable of supporting a total of 16 digital outputs. They're numbered 0 through 15. And the aux I/O cable gives you access to the last 2 of those outputs. So I've shown here the light green wire maps to output number 14 for base 0, which is going to be the second to the last digital output. And here, this is that same view of the programmer calculator, but instead of having it default to the decimal version, I chose to show the bit pattern up here so you can see that a little more clearly. But hopefully you can see this value here equates to the decimal or integer value of 16,384. So if I send out a digital value set to that value, it's going to carry that TTL signal out on Kronos's green output number 14. And then similarly, there's the second digital output maps to the last digital output, Again, since we're zero based, that's output 15, 0 through 15, total 16 outputs. And this bit pattern where only the 16th output is set maps to decimal value 32768. So those are the values that we're going to send. I also wanted to take a moment to show you whether you're actually working with a Kronos device or not. We incorporated a very similar tool into Kronos. And since Kronos is installed with every version of e'Prime3 by default, not e'Prime2, but it's installed with e'Prime3 by default, you can do a separate install for e'Prime2 if you need. You can access these Kronos device properties. And hopefully you can see that this works very similar to this programmer calculator. Again, Kronos labels its digital outputs 0 base. So again, this is digital output 0. This is digital output 15. This is interactive. You can click here. So I clicked on digital output 14 to show that that should be set to a 1. And over here, that shows the same integer value that we saw with the programmer calculator. So this can be super handy just because you're already working within eStudio. All right. Let's go ahead and take a look at this loopback task. Hopefully you can see this is an incredibly simple experiment. There's not a whole lot going on. The core action is actually on this stimulus object. We'll go back and take a look at this trial list in a minute because we'll be referencing attributes on that trial list, but I wanted you to see how the task event is structured. Up here was that the view that we honed in on earlier. This is where I list the events that I want to have some type of response, some type of action triggered by. I believe I failed to mention that indeed you can define multiple events, and in fact you often need to do that, to define multiple events. The first one here, I've chosen to look at the stimulus onset time. So when the onset time happens, I want something to happen. What do I want to happen? Well, down here on the left, this is the action part we talked about. This drop-down list here allows me to pick which device I want to carry out my task. Again, I'm not sure how clearly this comes over. I have not added a socket or a serial device or a parallel port device or a clear view device into my experiment. If I had enabled those, these would be clickable. They are not. I can't add them, but I have added a Kronos device, and that's the device I chose. Once you pick the device, then you can click on the action field, and this is where you have a list of options. And this is where a lot of people get confused because there's a lot of things to choose from here. Well, first of all, we know we want to send out a digital value, so we could ignore the analog values. They are not relevant. There are bit-specific values listed here, and there are non-bit, multi-bit, or numeric-based values, byte and integer. Depending on the value that you need to send, that dictates the value that you pick here. If you recall, when we looked at that prior image in the programmer calculator and also in the Kronos device digital out settings, I only want to set either the second to the last Kronos digital output, which is the 14th bit, or I want to set the 15th bit. I only want to set 1 bit high. And that's why the appropriate action here would be digital out set bit. Sorry, I got ahead of myself. We're going to show how to do digital out set bit. We're going to start by writing out the integer value. So if you remember, it was 16,000, I think 345 was the value for the 14th bit. And then we saw the other value for the 15th bit. So I'm going to tell Kronos, write out an integer value. The value I want is going to be dictated by the attribute that's defined as the trigger value. And we'll look at that in a minute. And that the data type for that value is long. This is another big point of confusion about this data type. Well, I'm calling write out integer and I have a long, and how is that going to work? The long refers to the value that you're actually specifying here. And we'll see we're going to have a value that's bigger than the maximum integer value you can hold. So that's why we need to define this as a long. Also, a very frequently underutilized feature is this enabled field. By default, it's set to yes. So that means whatever task event I'm using, I've defined here is actually going to execute. There may be times where you don't want to have your task event fire. Maybe you're having trouble getting them to work correctly and you've defined several and you're not quite sure which is the right one. Instead of having to actually remove the entire task event and then remember what those settings were and set it back, you can simply toggle this to no. That's all you have to do. And if you do that, then ePrime will not execute that task event. By default, it's set to yes, but it can be a super helpful debugging tool. All right, so that's the first task event we defined. And then we have a second task event. Second task event is also being carried out by Khronos. It's also calling digital outright integer. But instead of referencing an attribute value, it's referencing the value 0. And it's enabled. What we're doing here is for Khronos and for the parallel port, we always recommend that you clear the signal after you've sent it. Once we send a marker out, that digital line, that TTL 5 volts remains a constant high until we reset it again. So if you set a value high to say this is when the stimulus went on screen, and you never set that trigger back low, then you're never going to be able to recognize when the next trial happens, when the next trial comes, because that signal remains high the whole time. So our recommendation is that you leave a signal up for a minimum of 10 milliseconds and then you clear it. Now let's go back and look at one other critical feature I didn't mention previously, and that's this delay field. You'll notice I have 2 task events defined for the same event, the onset time, but I don't really want them to fire at the same time. I want one to fire to tell me when the stimulus came on screen and one to clear it later so that the subsequent trial, I'll be able to see whatever trigger is sent. That's the purpose of the delay field. In this specific example, we're saying 100, and this units are milliseconds, 100 milliseconds after the onset time happens, execute this task event. So the stimulus will be put on screen, and then 100 milliseconds later, we're going to send out the trigger. And this one, the second task event, is going to say 200 milliseconds after the stimulus onset time. This is when I'm going to set that trigger back down to 0. Again, we recommend a minimum of 10 milliseconds here. That's sufficient for most pieces of hardware. Your hardware needs may differ though. They may need to be signal set high for 50 milliseconds or 100 milliseconds or whatever is dictated by your external equipment. But usually 10 milliseconds is a good rough estimate. Now, you might be wondering, why are we setting this at 100 milliseconds? Why wouldn't we want that to come right when the stimulus onset happens? Well, because this is both illustrating how to set a task event to send something out, but also we're going to read in that task event so that we can confirm that the signal went out. We're going to have a delay of 100 milliseconds, and that means we know that every single response time that comes in, representing the Khronos device receiving that digital output and registering it as a response, should happen at 100 milliseconds. Okay. Well, what values are we actually sending here? This, by the way, this task is referred to as a Khronos loopback experiment. It's designed to allow you to test either that I/O expander, which you might remember from an earlier slide with those 16 digital outputs and inputs in the analog, or to work with the aux I/O cable. What we see here is an independent variable being logged that tells me which digital output are we affecting, which one are we writing to. Now this is one based, so this is the first digital output, which is digital output 0. This is the 8th digital output, which is digital output 7, and so on. We're only dealing with these last 2 digital outputs here. So we want to affect the 15th and the 16th. And this is the integer value that corresponds to those digital outputs. All right, let's go ahead. Let me show you one other. Need to make one quick change because the way that we're going to run this experiment over Zoom, I want to use a keyboard response instead of the button response. And this little piece of inline script, this is what allows, you'll see there'll be a prompt that says you were using the IO cable, the aux IO cable, or the IO expander. Since we're using the aux IO cable, we only have 15th and the 16th, the last two. So this little piece of script is simply going through this trial list and setting all of these weights to 0. So it's just a nice way to have this experiment be written generically so it can support either Cronus output option. So I'm going to go ahead and run this in windowed mode. There's not a whole lot going on. As you'll see, there'll be a display that tells, and it's asking me which option I want. So I want the aux IO cable, and there were just 2 quick displays that said sending out 15 and 16. Okay, so that didn't look too exciting, but what can we actually conclude from that? This is the data file we just ran. I ran a subject 55. This is the trigger value from the list object. This is the response that Cronus detected, and I'll show you how we set that up in a minute. And this is the stimulus RT. So we see in this case, there was actually a 1 millisecond difference between the RT that we expected. I'm going to assume that that's a function of running in windowed mode over Zoom. Hopefully you're familiar with running in windowed mode. It's a terrific debugging tool. But it is not recommended for real-time data collection because it doesn't run the same precise graphics routines. But in general, this is these are the results that we actually expect. So just to close the loop on this so that you understand how we were actually able to confirm that we were actually sending out that trigger. You'll see here that on the same object, this is the same object that we defined the task events for. On the same object we defined the task events, I created a Cronus input mask and allowed any key response to be made. Cronus features on its response is a concept called pseudo buttons. These 5 buttons here represent the blue buttons that you saw on the image of Cronus. And if somebody presses the leftmost button, it generates a response of 1. They press the rightmost button, it generates a response of 5. That seems pretty intuitive. If you have a microphone plugged in, you're collecting vocal responses, then we will generate a pseudo response of a 6. So if you see a response equal to 6, you know that that response was generated from the voice key. Well, over here, the 14th and the 15th responses, 14th and the 15th digital out corresponding to the 15th and the 16th outputs, these are designed to generate a response of F and G. So again, since I connected the wire corresponding to the 14th digital output into the first digital input that was supported, that's going to generate a response of an F. And similarly, I took the second digital output and wired it into the second digital input, and that generated my response of G. So that's why I am seeing the F and the G responses coming in. This is, you might notice this is a separate data run. I ran that this morning earlier in full mode, and you'll see that the RT for both of those cases was 100. All right, so I hope you understand why we wanted to illustrate the ability for the responses to come back in. A lot of times when people are having trouble with their task events, they have them set up and they say they're not receiving their triggers. They often, I think it's a natural inclination to say, well, maybe my triggers are actually not being sent out. How do I know that it's actually being sent? Because you can't physically see anything. If you happen to be using Cronus, and then you will have an aux IO cable, and using that aux IO cable is a really nice way for you to confirm indeed that that trigger is going out. But the other reason I wanted to run this experiment is I think it's a great example to help understand this issue of the different methods that are available to specify the values that you want to send. So you saw here that we went ahead and figured out what is the integer value that corresponds to the bits that I want to set high. Maybe you don't want to think integer-wise. Maybe you're more comfortable or you prefer to think in bits. So we know that we're really only sending an individual bit high, bit 14 or bit 15. I wanted to just show you. I don't think we're going to have time to run it, but I'd like to illustrate if we wanted to change this, instead of calling write integer, we wanted to call one of the bit specific methods, what value we would put. So I just created a new attribute called bit number. And I'm going to specify a 14 and a 15 here. Because again, the bit numbers are 0 based. If I wanted to specify a bit based method instead of an integer based method, instead of saying write integer, and this is where I got ahead of myself earlier, I'm going to call digital out set bit. But instead of giving it the trigger value of 16,000 and change, I need to set the bit number attribute, reference the bit number attribute. And that number is just going to be an integer. It's a value less than 32,767. That's all I would need to do to change things to being a bit representation. So again, this is where there's a lot of confusion because there are multiple ways to represent the same number. But before we can advise you about how to set that number, how to convey that information, you need to be clear on what values you actually want to send. Now, again, in this case, if you have the aux.io cable, you can only send 2 different values. You can only send 2 different triggers. Well, actually, you could send 3 because you could set both bit 14 and bit 15 high. But if you wanted to send both of those high, then you couldn't use the bit specific methods because the bit specific methods are bit specific. They're only turning on an individual bit on or off. So well, let's just look at that real quick. How would we actually set both of those bits? Well, if I'm not remembering my binary math very well, I'm just going to pull this up on the digital outs. And what if indeed I wanted to set 14 and 15 high? Well, it turns out that corresponds to integer value 49,152. So if I wanted to set both bits high, I could call write integer 49,152. And that's going to set both of those bits high until I choose to set them back down again. So I hope that that comparison makes sense to you. There is no difference between calling set bit 14 high, like I just illustrated here, and what we did originally by calling write integer with the specific trigger value. There is no functional difference between the 2 of them. So at that point, it's a matter of choice. If you need to set multiple bits high, then you can no longer use a bit specific value, and you would need to use either a write integer or a write byte call. And if you ask us what you need to do, of course, we can't tell you. Again, you're going to have to know what values you're expecting to see. Some systems that are receiving triggers don't actually display the number. They just display a marker. If you literally just need a line to say, this is when the stimulus came on, then it really doesn't matter. You can set any of the bits that you have available. If instead, for your purposes, your data analysis tool, your EEG tool, or whatever trace tool you're looking at does allow you to put specific values up, or you're doing something like the triggering the AirPuff or triggering an aroma, where the value you're sending is actually providing a specific instruction to the piece of equipment that you're communicating with, then you would need to use the appropriate call to send that specific value. Okay, I hope that's helpful. I see we have a couple questions in there, so I'm hoping, actually, maybe there aren't a couple questions. I think I misread that. Let's take, as we're closing out of time, I want to briefly take a look at a second example. It's a similar idea to Kronos, but this is using a serial device. And it's doing a loop back again for the purposes of being able to illustrate that we can both send values out and receive them back in again. I want to focus on the sending though, because once you know what device you're actually using to send out your trigger, then the actions that become available will vary depending on the device. So let me back up. I actually do not have a serial port on my computer, but I do have a nice serial port emulator that lets me run as if I actually use it. Creates a virtual serial port. And for the purposes of this demonstration, I actually created two serial devices. I added two serial devices, one serial out to send out the signals and a second serial in to send in. So the name of my virtual serial device that's going to send out a trigger is called serial out. So that's why that's the name of the device that we're sending, that we're choosing to carry out the event. And again, we're triggering on the onset time. Now the actions that appear here, because I've selected, pardon me, a serial device, they're different. You notice you don't see a set bit, reset bit, any of the bit specific methods that were available for Kronos. Now we see a whole bunch of different ones, but these are appropriate for a serial device. So one nice feature of serial devices is that they can be used to send out a string. So a string, a series of characters. Again, the example, if you needed to actually send a command like stop or start to an external device, you may need to send a string value over the serial port. However, you can also send numbers. You can send a long value. You can send an integer value. You can send a single byte, if you remember from earlier, that represents 8 bits. Or there's a variety of devices that require an array of bytes to be sent. The trigger box is one of those devices that requires a write bytes. You can call that to set a series of bytes to be written out. So again, the actions are specific to the device. What this example does is it walks through all of the different actions that are supported by the serial device, and it puts a specific marker value, that's an attribute there, and it changes the data type depending on what it's sending. So how do we structure this? Again, it's very similar to how we set things up for the Kronos loopback. You'll see this goes through the same actions in the same order that we saw in the event part dropdown. So we either want to call write string, write integer, write long, write byte, or write bytes. Calling write string, the marker value we send is actually a text string called hello world. So we actually literally want to send the string values, the character values, HELLO space WORLD exclamation point out. And the data type here is string, because again, the data type refers to the actual parameter value you're sending. This next example, we're writing an integer, 32767 is the integer we're writing, and it's a data type of integer. That is the maximum integer value you can send. A long is another numeric type. If you're not familiar with it, it just stores a much wider range of whole numbers. So we're sending this large long value with the data type of long. Write byte, we're sending a value of 2 with the data type of 2. And write bytes, I'm not going to get into this because we need a little bit of script to interpret that, but that's a way that you could represent a hexadecimal string. So hopefully you see it's a similar structure. Depending on the action that I want to call, I'm going to send a different value. And the combination of action, marker value, and data type have to make sense for the method that I choose. So that's how we set that up on the slide. As opposed to what we were able to icely do using Kronos and simply set up a Kronos input mask to accept input, similar to how you would accept input from a keyboard or a mouse, there isn't a way to specify the serial device as an input. So we needed to write a little bit of script to do this, and I'm not going to go through this script in detail now, but the long and short of it is we retrieve the attribute from the list, which identifies which action we're looking at. Let's assume we are doing write string. Case write string will evaluate as true, so then we're going to do whatever script is here. And what we're going to do is call the read string method on the serial input device. So this is an example where we actually need to use eBasic script. I don't have a GUI alternative, but the read string is one of the methods supported on the serial device to read in a specific string. And the string that we read in, we debug.print, and we also identify how many bytes of information we read. I ran this earlier, and we can take a look here in the output window about the information that we actually read in. So on the first trial, we read in a value called hello world, and that took a total of 12 bytes, corresponding to 1 byte per character. Then the integer value here, 32767, reading 2 bytes. The larger marker there, it actually took 4 bytes, and so on and so on. So what I'm hoping to convey by looking at this serial example as compared to using the Cronus example is that at a very high level, the structure of the task event is very similar. You need to come into creating your task events, understanding what value you want to send, and then you need to fill out the specific values appropriate for the tasks and the methods that you need to present. All right, I'm going to jump to the conclusion. Well, let me jump to the common points of confusion in our recommendation. Again, we've been talking recently about data types. The selected data type is for the parameter value. So whatever parameter value you're specifying, that's what the data type links to. Sending triggers with Cronus in the parallel port, you need to make sure to clear those signals again with a recommended minimum 10 millisecond delay. One piece we did not get to, but I do want to take a moment to touch on it because it is important. If you're clearing, many people like to set the trigger at the stimulus onset and then turn that trigger off on the stimulus offset, because whatever software they're using to display those triggers will display a nice line across the top to let you know this is the duration of my stimulus. So choosing the offset experiment event is a common sense way to denote the end of that stimulus presentation. That works fine as long as the pre-release on the object that is presenting that stimulus is set to 0. So if you're not familiar with pre-release, it's specified on the duration input tab here. By default, it's set to same as duration. And what pre-release does is tell ePrime, process this object, present the stimulus on it, whether you're presenting text or a movie, playing a sound, images, whatever. And then for whatever amount of pre-release time is left, work ahead, look ahead to see what the next object is that's coming and do some pre-processing work. The point of doing that is to reduce, hopefully eliminate the delay between the presentation of one object and the presentation of a second object. However, pre-release impacts the calculated value for the offset time. So if you're using pre-release, then your offset time is going to happen much more quickly than what you might expect. In fact, it's going to happen very, very close to the onset time if it's set to the full duration of the object. So sometimes folks come to us saying, I have my trigger set up, I'm sending it out, I'm clearing it, but I never see it. Well, that's because ePrime is processing so quickly before it has actually written out that first trigger at the stimulus onset, it's going ahead and clearing it because you're using offset. So that is one of our most common questions related to task events. So I want to make sure I got that in. All right, so in conclusion, again, this slide presentation and these links will be made available when we upload it. But I do want to let you know that there's a series of articles, pardon me, knowledge-based articles that basically walk through the same issues that we walk through. There's a high-level article, how do I send markers to the device? And it walks through, these are the devices we support. This is how you add that device to the experiment. How do you go about choosing a marker value? And it reviews the information we looked at about binary numbers. There's also a general article about using task events that reiterates a lot of these points. And as I mentioned earlier, we do have another webinar that's simply looking at focusing on analog input, receiving analog input into ePrime. So I appreciate everybody attending and coming. I don't know if anybody has submitted any questions. I know we're just over, but we could take a minute or two if there's any questions. If not, again, we thank you so much for your participation. I hope this information was helpful. Be looking, hopefully by the end of the week, for this information to be uploaded to our support site. And again, please, 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 we can't encourage you enough. Any questions, whether it's related to markers or anything else about ePrime, please email our support team. They do a great job. They really want to take care of folks and get your questions answered. So we will walk you through this process. If you have a vague sense of what you do, but you're not really sure how to take the next step, please let us know. I'm not seeing any outstanding questions. I see that somebody asked a question and it got addressed. So I'm going to go ahead and end the meeting. Again, thank you all so much and have a great rest of your day. Thank you, everyone.